In this video, we're going to begin to learn about similarities, especially similarities of polygons. Polygons with same shape but different sizes are what we call similar polygons. So let's say it's shape here, different sizes. And more specifically, we say that they're similar if their corresponding angles are congruent. And then their corresponding sides are proportional. Seems to be common sense. And the ratio of corresponding sides is called the scale factor, which is a really important concept. If you are going to become an architect or somebody even do home improvement projects, the scale factor obviously becomes very important because you can't draw a house as big as a house or a building as big as a building. So you have to shrink the entire building into a piece of paper, onto a piece of paper, and that's and you have to do that shrinkage by proportion, right? While keeping the angles the same. So if polygons are similar, then their parameters are also proportional, just like their sides. Okay, let's dig in a little bit more on scale factor. I don't like how this part of the material is organized, but I'm going to use this example on the right with the two triangles. And let's discuss scale factors. First of all, let's look at the triangles. By definition, we say that polygons with triangles are similar if they meet two criteria up here. So if you look at the two diagrams, it demonstrates that all the angles are congruent, right? This is congruent to that. So all the angles are congruent to the corresponding angles in the second triangle. And then the next thing you want to look at is you want to set up the corresponding sides. So angle A is 10, and angle A is congruent to angle D, and angle D's corresponding side is 15. And you look at the ratio between the two sides. And then next thing you want to look at is angle B, its corresponding side is 18, and angle E is 27. And the third one is 8, and that's 12. And if you simplify it, you will come to realize that they are all the same ratio. So, and that's our scale factor right there. So, and that's what here means. It says order matters. So you really have to go look at, I did 10 over 15. That's because I looked at angle A from the first angle, and then I looked at the corresponding angle, angle D, and what faces angle D is 15. So you cannot go from 15 over 10, then you won't find 2/3, you'll find 3/2. So, so again, you first want to find out if it has all the corresponding angles being congruent, that does it fit the first criteria, and secondly, are all the sides proportional or not. And that's how you find out that once you draw the conclusion they're similar, really you take one side's, if you just, at that point, if you just take one side, if you say, if you just give me that, and you can prove to me that's the scale factor. So that this leads us to similarity statements. Similarity statements, just like congruency statement, they must match corresponding angles and sides. And we use this little wiggly thing to denote it. So in our example above, we would say triangle ABC is similar to triangle DEF by definition, because all the corresponding angles are congruent and all the corresponding sides are similar. So a quick example, triangle JKL and triangle PMN. We have to list all the congruent sides, and we know that there are all the congruent angles and write the proportions. So let's see. So J and P, so here J and P, and K and M, so K and M, and L and N. So J is congruent to angle P, angle K is congruent to angle M, finally angle L is congruent to angle N, right? And now I look at the corresponding sides. J is KL over P is MN. That scale factor should equal K's corresponding side is JL and M is NP. And finally, L is JK and N is MP. Okay. Let's look at the second example. I have triangle XYZ, and inside I have triangle RYS, and they're similar. So X and R, so X is here, R is here. And Y and Y is here. So they have an overlapping angle. So I should use a different symbol. And Z and S. So that's angle X is congruent to angle R, angle Z is congruent to angle S, and angle Y is congruent to itself. Just a quick reminder, if I have these two angles being congruent, and I can prove that they are corresponding angles, so if you use corresponding angles converse, you can prove that these two lines are actually parallel. That's just a side story there, okay? So now in terms of the sides, this is actually a lot easier to see. If you look at big triangle versus small triangle, so XY over RY should be the same as XZ over RS, should be the same as YZ over YS. Okay. Finish number 3 by yourself. Let's look at number 4. Using similar figures to solve for missing angles. So first one, I have the two polygons below are similar with a scale factor of 2 to 3. Find the value of X. And obviously this is the small one, this is the big one. So that's actually how do I get rid of that? Where's my eraser? Doesn't work. All right, I'm just gonna write it over. So this is the big one. So this has to be the 2, this has to be 3, right? So what I will do is, because the scale factor is 2 to 3, then one side for the small polygon is 42. The other side, the corresponding side in the bigger polygon would be X. So now I cross multiply, I should come out with X equals 63. Let's look at number 6. Oops. Sorry about that. Number 6. Where is my eraser? It doesn't work. Two triangles are similar, ABC and DEF. I've defined the value X. And in this case, I'm giving two sides actually. So I can find the scale factor. Again, be very careful. Do not just randomly pick one side of each. You have to use these angles to figure out which one corresponds with which side. So if I'm looking at 25, 25 is facing C, so I have to look for angle F right here. So if I set up this one, 25 over X, that's my scale factor. Then if I want to use 20, I can use the other side is 28. Okay, if you cross multiply, the answer for that should be 35. Again, if you can't just use 25 over 28, you have to know that 25 is corresponding to C, and the angle F, which is congruent to angle C, the corresponding side is X. so you have to set it up accordingly. Make sure everything is aligned. Finish 5 and 7 on your own. And then let's look at number 8. Here I have two similar triangles. So all the angles are congruent, the sides are proportional, and I'm asked to find the corresponding value of x, the value of x. The setup is exactly the same, except that it's a little bit more steps in terms of algebra. So let's do the easy part first. If I set it up, the 32 corresponding side would be x plus 3, and 36 would be x plus 6. Now if I cross multiply, 32 times x plus 6 should equal 36 times x plus 3. I notice that I can cancel a 4 out of it, right? Now I can distribute. Oops, this is an 8x. And if I do my algebraic manipulation, minus x on both sides, minus 27 on both sides. I'm switching sides a little as well. So I should have 21 there. So that's my final answer. Number 9 is fairly similar as well, so finish number 9. I don't know if I mentioned that you should finish all the problems that I didn't do on this in this video. Okay, so good luck with this unit. It's proportions and polygon similarities. It's a little rough at the beginning, not because it's hard to understand, but because it's just quite a bit of information. You have to constantly looking for corresponding angles and corresponding sides. But take your time. The concept itself is not hard at all. It's just a little tedious. You all can do it and can do it well. All right, guys, I'll see you in class. Bye.